Alright, well, just in case you've been wondering, just what in the hell is that guy going to build next? I'll give you a clue. Did you guess bridge? This is a little bit different here as far as bridges go, because we can't change the elevation of the county road here. Can't change the elevation of them railroad tracks there. We're going to use the old bridge footers from where they had a wooden bridge here. There's a real good footer right there, right there, right there, and there's one underneath the dirt right there. So we got 4 places to hook iron to, but what's strange is with these elevations, this bridge is going to fall at an angle of about 1 1/4 inches per foot. It's almost 5.5 feet higher here than down there. 5'5", I think, to be exact, that side there is lower. So we're going to be building a bridge here that goes down on a slope, 52 feet long, 14 feet wide, and we're going to do it by using 5 I-beams with channel across them to support them. And on these footers at each side of the creek here, I'll be building some steel piers that will fasten to them to give it some more support. So yeah, better take some measurements, huh? Taking a little look-see here at the other side. I'm over here on the railroad track side. Got me service truck over there. I was up here with the old Ford this morning, and I parked right there, and when I got out of the truck, I shut the truck off. I got out of the truck, and I realized that I could have got out of the road a little better. So I figured, well, I'll move out of the road. I don't want somebody to hit my truck. So I jumped back in the old Ford where it was parked right there and went to fire it up, and she wouldn't start. Battery was dead. Just barely tried to crank. And I took 2 screwdrivers and 2 flathead screwdrivers and 2 boxed in wrenches, and that 60 volt DeWalt tool battery over there, and I jump started the old girl and got her home. You might not believe that, but that's the truth. See, I told you, like, that's how I jump started that truck and got her home. I ain't kidding you, or I'd have been stranded up here. So I'm taking a look at that. You might not be able to tell. Oh yeah, you can see my strings. I got a couple strings here run across, and I've noticed that on this side, it's amazing how level most of this concrete is. That abutment over there is nice and level. The abutment over here is nice and level. For some reason, this abutment, looking at it this way, is way out of plumb, which doesn't make no never mind. It's pretty level. Pretty close to being level looking at it that way, which that doesn't really matter either. I am going to want to cut my beams where they come down here. See, this string would be the bottom of the beam, and I'm going to want to cut them beams off at an angle. And when I put a framing square up here, of course this side of the framing square here is 16 inches. That's the height of my beams. I'm using 16-inch beams, and if I line that square up, if I line the 2-foot side of that square up with that string, I got a gap right there that's about 1 inch or 1 1.25 inches, and that's going to be close enough to tell me how to cut the angle on the beams on the end, because that's not a critical cut. I got 1 inch over there, and I got 1 inch and 1 1.25 inches there. That pretty much tells me that deal. This string where I run it across from that tap con to this tap con, I run a line level on it to tell me where to put this tap con, and then this string would be the other side. Of course, they're 14 feet apart. So these strings would be the bottom of the outside beams on the outside corner pretty much. There will be angle iron on top of the bridge with Q decking, and the angle iron where it sticks out 3 or 3.5 inches, you know, it makes the 14 feet. But I'm going on and putting the strings at 14 feet to show that. And I think I got what I need here. So I'm going to move some stuff back over to the other side. On the Millermatic 252, 25.6 volts, 451 inches a minute. The wire in here is a 035 diameter, ER70S6. This gold gas is 16% carbon dioxide, with the remainder being argon. A 1-inch plate to the 15-inch channel. That channel is 15 by 40 pound a foot, 15-inch channel. Be pushing that with about a 30-degree push angle. Just between a short circuit and a spray. So the solid wire MIG, you can really do some welding with it on clean material. This is all brand new stuff. The hoist is still in place on that channel just to be safe. The channel's really setting on those two shorty jacks. So moving the channel up and down to get the height right, obviously the jacks make it easy to do that with the thread. Just turn that handle and get your height set right. But now I'm really close. I just need that channel to go that way. And if you ever tried to grab something like this when it was sitting on a set of jacks and slide it just doesn't work. I'm going to show you how to adjust this and get that to move just a little bit and not lose what you got now that it's all pretty close. Rather than try to move the channel on the jack, I'm going to move the jack to move the channel. I went a little too far. So by tapping on that head and slipping that jack's position on the channel, I'm able to move the channel left and right to get it on my lines. So I'm fixing to haul the piers up. These bridge piers, I'm going to leave them up at Dalton's shop. If you wonder about when you haul them, if you ever wonder about how many straps you should put on it, if it looks like this, I'd say go with all of them. Yeah, I'm sure it'll be fine. Headed out to the bridge site with the old Ford. Got a new battery, a new starter. I give her about $50 worth of AC Pro in the old AC there. It's probably going to leak out, but she's blowing good now. Look there, she's blowing so good she's freezing the windshield. Put the welder skid on there. Going to need to do the little ticky-tacking with that. I got 1,100 pounds of concrete on the back of the 10-foot flatbed, and that's nowhere near enough shit on the old girl, so I'm gonna go get the 20-foot car trailer with them two bridge piers on it. That'd be another 7,000 or 8,000 pounds, and we'll head to the site. I mean, I think it'll be fine. Look here at the steps my boy Dalton made for me to get down in here. He's a good cracker. You can't run a hoe in West Virginia and be a pussy. Well, we got them things set. He's coming up out of there. We were going to grout those today. And Dalton had the thought that while we're setting them I-beams for the bridge, we might end up setting them on them piers. We're not exactly sure how we're going to set the beams yet, but I was a little bit concerned about busting the grout if we were setting the beams on there and they slid or something like that, because you'd have 10 foot of leverage against that base, and that base isn't made to be banged on at the top like that. It's supposed to be welded to the bridge. And Dalton said, well, maybe we'll just grout them later, and that's a fantastic idea. They're fine the way they are with the pins in there. And if something happened, they got a little knocked out of plumb or some weird shit when we were setting the beams, it'd be real easy to fix them. And then we'll just grout them after we're done. So that's the plan. Pretty happy with how that went, setting them there, and everything looks good to me. So we got them bridge piers put in. I'm back at the shop fabricating the bridge. Got this 10-inch channel, which is what's going to be between the I-beams of the bridge. This bridge, you know, it'll be 5 I-beams. And there's going to be 4 channels between these beams. The 2 outside beams, these 2 and these 2, will be welded together. There's also going to be channels between this center beam and those outer beams, but we're doing that with a bolt connection in the middle. So you're going to have these 2 I-beams welded solid together with the channels between them, and then a piece of channel sticking off of it. Same thing here, 2 I-beams, channel welded in between them, and a piece of channel sticking off of it. Then your center I-beam is going to be 1 I-beam, piece of channel sticking off of it. So I'm hoping by looking at that right there, you can start smelling what I'm stepping in here. See, this is where this is going to bolt together. I've got 3 bolts there, and the reason I got 3 bolts there is because I think 2 will hold it. So let's stick 3 in it. That'll be pretty ketchup and mustard right there. So these channels right here are the ones that'll be welded solid in, and they're 38.5 inches. Putting 2 of those together with a 6-inch overlap and the 3 bolts makes us a channel that's 38.5 inches. So how am I making those holes? Well, I'm burning them with a hand torch. People would do that on some people would do that maybe on a CNC machine. I'm going to do it on my CBP machine, which means I've made me a jig that I'm going to put up here just like this. Using a double-aught tip like I'm going to burn these with. If I follow inside of this 15/16 hole, it's going to make an 11/16 hole. And I'm gaining consistency here because I'm going to burn one channel like this, and then I'm just going to flip this thing over and do it again. And then these 2 will bolt together, and my pattern has got me set up really good. Now you could lay these out and punch them with an iron worker. A lot of shops I have worked in, we would do them that way. If you do that, generally it's a good practice to oil your punch. You could also lay them out and drill them with a mag drill. I got a mag drill. I actually used a mag drill to make these 15/16 holes. But in that case also, you would want to oil or use some kind of cutting fluid on your mag drill bit. You're talking about a $60 drill bit. You don't want to run that dry. But there's a disadvantage there because I'm responsible for painting this bridge. So any oil I get on it, I got to get that oil off of it. So if I don't get any oil on it, I've just eliminated a step. And I'm also gaining a considerable amount of consistency here because I'm pretty much making all these holes the exact same way with the exact same jig. It'd be hard to goof this up. It'd be hard to have holes that didn't line up based on the way I'm doing this. So let me show you what it looks like. All right, next thing on this bridge, I had an idea to make a Z-beam. And this Z-beam that I was going to make out of some leftover channel from this job, the idea being that I would have a lower leg to anchor to the abutment, the cement abutment, the concrete, and I would have an upper piece on the angle of the bridge, the 1 1/4 12 angle, and they would face different directions, which would make it a little better for grouting the piece in place and a little easier for drilling the holes to anchor it. My idea was to take a piece of this 10-inch channel that was left over, and I was going to take my track torch and split it. And day before yesterday, I did that. I did it wrong. There's several things I realize now I could have done different that would have helped. But overall, just to get to the point on it, I destroyed that piece of channel. It warped and twisted so bad that it was useless, and it did it so fast as the track torch was cutting it that at one point the torch was cutting 3/4 of an inch off of my cut line. And I got so pissed off, I realized there was no way I could use that piece up. I cut the piece up and throwed it right in the scrap. It doesn't look that twisted now that it's cut up into 4-foot pieces, but believe me, it's useless. There's nothing straight about the cut. The piece that twisted so bad, I quit on that. So I've been thinking about other things that I might do. But my biggest problem was I really wanted to make that beam, and I'd like to try again, but I realized that the other piece of 10-inch channel that's left over from this, it's just not long enough. It's not 14 foot. And the amazing thing was, I was straightening up some metal in my Connex box this morning, and guess what I found? I have another piece of that 10-inch channel. I don't know where it came from, what it was left over from. It's not long enough, but that combined with the other leftover piece that I got, I mean, I got a Miller-Matic that can make these two pieces one, and it'll be long enough. So that's where I'm going with this thing. I'm going to splice them together, and I'm going to try again to make that Z-beam, because that's what I wanted to do in the first place. And I don't think I should let my little goof there the other day stop me. That whole deal with messing up that piece of channel, it aggravated me pretty bad. I actually didn't work on the bridge yesterday, and that's uncommon for me, because usually, I mean, when I'm working on a project like this, I like to get on it and stay with it until I'm done with it. But I picked some beans with the neighbor boys yesterday and mowed over at the rental property and did some other stuff. But let me tell you what I'm thinking here. That abutment over there where these beams would land is, you know, it's shaped like that. So you'd have your I-beams. The thing is, the bottom of our I-beams and the angle they come in on, it's about 8 inches from here to the level place in that abutment. So our I-beam's going to be coming in like this, and we got to set it on something down here that'll put it in the right place. So what I'm wanting this Z-beam to do is be about 9 inches tall and go like this, with the top matching the angle of our beam coming down. When these 5 beams are like this, there would be an area in here we can fill up with concrete, and that would ultimately be the bearing surface under our I-beams. But during the time that we set them, it would just be this Z-beam here to set it on. So you could have anchors going into the cement holding this. You may even do you an anchor, you know, at an angle or something. But this surface here being close to the angle of the I-beam coming down would give me a place I could weld those together, which, you know, that would help a lot too. So that's my plan. I'm going to splice these two together. I'm going to try another technique for splitting them open, splitting them in two together, or splitting them in two so that I can flip them around and make them a Z instead of a C, and get them on the angle that I want them. And then while I was doing this, getting that metal out, I figured I'd just show you. This is how I got my metal in my Connex. I've got this rack in this side of the Connex that takes the longer stuff. Now my Connexes are the type that have doors in both ends, so there's a door in the other end and I have a rack in the other end. What it does in the other end is it takes sheets of stuff. There's, you know, sheets of plate and expanded metal and whatever that lays in there flat. But both of my racks have wheels on them. They're like little trailers, heavy duty trailers. So I figured I'd show you how my metal racks work, since I got that thing out of there and was getting some metal out of it. I'll push her back in and we'll show you that. I just put you right here like this here. How about that? Getting this set up, a couple things I'm gonna do different this time. I got the channel clamped down the table. I got the track clamped down to the table. If I want to keep cutting where there's a clamp, I can always pull that off while it's cutting. But I don't think I'm gonna take off and make the whole cut in one lick. I think I'll cut a little ways and probably even use the water hose to cool it off and then cut some more. Another thing, when I messed up that other one, I started right here at the end like I was normally cutting a plate, and I just started cutting. I'm going to start cutting clear back an inch or so this way and leave some metal. And I'll probably cut a ways and stop and leave some metal and keep cutting that way in little pieces and cooling it down. So see if that fixes some of the troubles I had along with the clamping, and maybe this piece will come out straight enough I can use it. Well, I got that Z-beam made. I don't know what else I'm going to have to do to it to use it. Got holes in it. I got to get it in place really to see what's going on. So I got wheels on it. And I got my winchinator. Right there is my little winchinator and I got a bunch of rope and a snatch block, and this should be interesting. About to try some sketchy shit, doo-dah, doo-dah. Hope I get away with it. Oh, doo-dah day. Snatch block up there on that abutment. Winch line's running, so we're snatching and we're winching. So I pulled this end as far up here as I'm going to go, and this end needs to go over there. So now I got the snatch block over there, and the rope's running up to the winch over across the top of those piers. And something something to note about this, the way I'm operating that winch with this wireless remote, I read on there that you can operate the winch from up to 20 feet away. That was in the instructions, or on something that I saw. It said up to 20 feet. Now I'm running this winch and I'm over 50 feet away for sure. Probably more like closer to 60 feet away. And that's pretty ketchup and mustard if you ask me. Well, that's where I wanted that to be. So now I got to retract up my winch. The cable's clear out pretty much. So I just pile up them wheels and clamps and ropes and winch them up the hill while I'm putting the winch away. That went all right. You got to make sure when you're doing something like that that you're not behind it, you know, you're not downhill from it. That thing's 300 pounds. And there was a few times I went up there and I grabbed it and I helped it and I did things, but I didn't get behind it. You always got to think, what are you going to do if something breaks? All right, moving on. So ultimately, if you were building something like this and you were pouring the abutments or the concrete or whatever, you'd put anchor bolts in and cement those anchor bolts in when you did it. Obviously we don't have that luxury here, and when you don't, you got to use something to anchor. A lot of people use wedge anchors. I really don't like wedge anchors. I've broken concrete when I was a kid using wedge anchors. If you go to a quarry and see how they break rock, they pretty much do it in the same manner as a wedge anchor works. It's like those things are made to break cement. But anyway, something I do, I'm hammer drilling a 1-inch hole here, and I've got 1-inch pins, and I'll put that 1-inch pin in the hole, and it's something that's going to work somewhat like a nail. They fit pretty tight in the hole, and of course you'd watch your depth so that you could drive it in so it bottoms out. And what I'll do is I'll just weld this pin. I'll just weld it right to this Z-beam. And so now down here where we may be at some point getting water, you know, down here there'll be times when this would be maybe underwater when there's flooding or whatever. Now I've got 3/4 pins that we put in there using the same method and welded them, but those 3/4 pins there, they're stainless steel. So, you know, that's a little more, a lot more corrosion resistant as far as rotting off at the base. Up here, this is going to be a lot drier environment, and I went a little bigger with the pins, so even if it half rotted off, there's probably so many of them in there. I'm going to have a lot of pins in this, but just want to make note of that. I'm getting back to work. I drilled that hole too deep, and the very last hit with the hammer, that pin went way down in there. It's so far down in there I can't even weld it. It's about a ½ inch too much to do anything with it. Dang it! I'm gonna start rocking that hole and send her back in there. I won't tell if you don't. Yesterday I got that Z-beam anchored in there. Another thing I did was I mag drilled some holes, extra holes in the bases of those piers, and ran some 1-inch rods through them, 4 more in each one, and drove them down into concrete 7 or 8 inches and welded those. The reason I wanted some extra pins in these is we had talked about if we get a little bit rough banging the beams around when we set the beams on here, you know, that would be kind of hard on those piers, and I figured I'd put some extra pins in there. And it was kind of an efficient thing to do because I was already anchoring and pinning for the Z-beam anyway. But I got all that anchoring done, got the pins welded to everything yesterday. I touched up the primer on everything yesterday. I primered over top of the cold galvanizing compound that I'd put on those bases. Before I done that, you know, I got a little pump. I put a pump in the creek and used the creek water and washed all this iron. And it's still pretty clean, so I'm going to go ahead and paint it. And this part, as far as the on-site, would be pretty much done. My I-beams for building the bridge are coming tomorrow, so everything timing-wise is working out pretty good. So I'm going to get to work on this and get that done. I really like these little rollers. These little small rollers. You know, with a lot of painting, if you use them big rollers, you need a paintbrush for some stuff, and you need that big roller for the other. And you know, if you're painting inside of your house, painting your sheetrock or something like that, those are really good. Where I'm painting this pipe, I don't need a brush because this is small enough to get into the areas that I need to get into. And with all painting, with a roller and even sometimes with a brush, I always like to have a pole. And even when I take the pole off and I'm using the thing without the pole gives me something to hold on to while I'm moving around, and it's kind of an extra steadying device that I'm going to use while I'm painting, reaching around and leaning. But I use the pole a lot. Now, a lot of people would say, well, why don't you spray that? Now, I do spray. I can spray every way there is to spray pretty much. I have an airless sprayer. An airless sprayers basically work mostly like a pump, a high pressure pump to spray paint. And I also spray paint with air. I have a small HVLP unit that I paint a lot of stuff with, like I painted the bed on my service truck with. I also have a 2-quart, 2-hand job where you hold it's air pressure, but you hold the 2-quart cup in one hand and the gun in the other and paint. People would say, like, on this, why don't I spray this? The thing that you would have the most trouble with in an environment like this if you were spraying is the hose. Now, whether it was your air hose or your pump line from your airless sprayer, you'd almost need 3 guys to hold on to your hose, because otherwise you can't watch the hose and paint at the same time. You'd be dragging that hose around in this dirt, getting it hung up on the roots that it's sticking out. You'd be dragging the dirt up above these piers down onto the wet paint on top of the pier bases. It would be a mess. If you had guys to hold your hose, or if you covered the area with plastic, you could spray it. I don't think there's enough painting work to do here to justify doing that. So I'm going with the roller. We'll see how she goes. One of the fun things that I do is I save plastic containers. This is a container from protein powder or something. Got a screw-on lid. I got a couple paintbrushes in there now and gasoline. I take those rollers, knock them in there, let it soak in the gasoline. I use these cheap rollers, and I use cheap paintbrushes. And people say, that paintbrush is only $1. Why do you use that more than once? When you first use any roller or any paintbrush, stuff will come out of it. Like if it's a paintbrush, bristles will come out of it. You'll find bristles in your paint. Even if you pay a little more for one, it'll happen. And rollers, when you very first start using a roller, you can clean them out, but still, when you first start using it, a lot of times you'll find some of this nap in your paint. That stuff stops coming out of there. So if you clean them and reuse them, they'll get to a point where the stuff just doesn't come out of them anymore. And it actually works better for me. Even with the cheap stuff, I clean them and use them until I just destroyed them and absolutely can't use them anymore. Works for me. So the Z-beam and both the piers got painted today. Got 2 coats of black on them. Perfect weather for it. Pretty much able to start on the Z-beam, paint it, paint the first pier, paint the second pier, and timing worked out to go straight back to the Z-beam and put the second coat on it. Might be able to see there how those are pinned in. 4 3/4 inch pins, 2 1-inch pins. The bottom of each post. Brought the service truck today. One of the small ridges guys hauling a load of logs, 2 load of logs. Done some welding for them too. Anywhooser, I'm out of here for today. Got steel. Let it down. Looking good. That's more straighter. Building the bridge. Take it easy, Miss Diane. Bees and bugs will see that light when you're welding and fly right into that. Bad idea. Good looking weld. Seal welding this angle to this beam with a 1/4 inch jet, 315 amps. I got the point of that chipping hammer at the start. So 43 inches we went. "43 inches we went with that rod. Something you might see, there's a glove jammed in the top of my hood there. One of the common problems with welding outside, these welding lenses will reflect like a mirror back in your face. And when you're welding outdoors, You know, if the sun gets behind that lens and shines back at you, you can't see a damn thing. That's the reason why pipeline welders wear pancakes. Their pancake hood is actually more of a goggle than a hood. Now, in the case with this, a common solution would be to put up an umbrella. And it would be nice to keep you cool putting up an umbrella, but I'm moving so fast, if I put up an umbrella, I'd have to move that umbrella so often, I'm not even going to fool with it. I'm just going to stick it out. I got that glove blocking the light that's leaking in the top of my hood, and that's how I'm going with it. I'm going to get back to work. Getting a shyster warmed up this morning, and I'm gonna make a little notes, couple notes, things going on with fabricating this bridge. And we originally planned this bridge for 6 inches of concrete, and I talked to a guy that's poured a lot of concrete, and I said, well, what is 6 inches of concrete when you're putting down a Q-decking material, which is a corrugated material? You know, what is 6 inches of concrete? And the feller told me, even though your Q-decking is a corrugated material, 6 inches of concrete is still from the bottom of the Q-decking. So when we said we wanted 6 inches of concrete, I got 6-inch angle, and it landed here, got all the steel in, and the fellers that are having this bridge built got a hold of me, and they said, can you add something, a bar or something to that 6 inches, so that we can have 6 inches of concrete from the top of the corrugated to really have 8 inches of concrete. And at first I said, well, I haven't put that angle iron on there yet. Let me see if I can get my hands on 8-inch angle iron, and then I won't have to add something like that on there. We'll get the right angle. My research brought up the fact that the only angle with an 8-inch leg that the mills currently are running is an 8x4.5, which is way heavier and thicker than what we need for something that's basically a concrete form. So even with all the welding of welding the flat bar on to this to make it higher, it's still a better, it's more economical to do this than to replace this with an 8-inch angle that's a lot bigger and heavier than we need. But what it does bring up is it's a tremendous amount of welding. It takes a little time to line it up, but it's a lot of welding. By the time you weld that flat bar on the side and you weld that angle iron on the side, that's 212 feet of weld, and that's got to be done on both sides of the bridge. So a lot of people would say, well, why do you weld that solid? Can't you just tack it on there or stitch weld it? Well, you can. Yes, you can. Absolutely. You could stitch weld it and it would be plenty strong enough. The one thing you need to know, though, if you do that on a structure, such a long-term structure as a bridge, is you're creating a place where water can get in and rust can ooze out, but you can never clean that place and you can never paint that place. If you put two pieces of steel together and don't weld it solid, there's going to be an area between those two pieces of steel that you can never treat. Something like this on the very side of the bridge, you know, if this is welded solid, no matter how bad this would ever rust, you could come to the side of this and you could clean it up and you could do a paint job on it and it would look like brand new. But you can't really say that you could do that and make it last if it was stitch welded, because if that flat bar was just stitch welded onto that angle iron, and 5 years from now you came and you said, I want my bridge to look brand new, I'm going to do a paint job on it. Well, you could sand that down and you could paint it and you could make it look brand new that day, and within a week rust could ooze out of that crack down your brand new paint and it would look like hell. So it's something, you know, could you stitch it? Sure you could. You could do this entire bridge and not put one bit of paint on it. You could certainly do that. The thinnest piece of steel we're dealing with here is 3/8 of an inch, and if you didn't even paint this thing, I probably wouldn't see a day in my lifetime, even under the worst conditions, that it would rust completely through. But if a customer says, I want you to build me a bridge and I want you to paint it, then you need to consider what do they want done? Do they want it painted in a way that it's going to be not only look good when you build it, but something that you could continue to take care of and make it look nice forever? It's just a decision that's got to be made. And in this case, I did talk to them about welding this solid. I explained the amount of labor that would go into it, and they were fine with it. They said, yeah, do that. So that's what we're doing. The other concern with doing this much welding on something is the amount that it's going to warp the steel. That's a lot of heat. When you weld steel and put heat on it like that, it shrinks. So it's something that you deal with. I did a little test yesterday as far as like when I was completely done welding this up and it's 100% seal welded yesterday. I took a look straight down the side of this thing, and it looked to me like, I didn't put a string on it, but it looked to me like I had about 4 inches of bow. If you was to run a string from one end to the other, I had about 4 inches of an inward bow in the center. So what I did was I just picked up the center beam, which is obviously here you can see it's bolted in there. I picked up that center beam and I bolted it on, pulled it together and bolted it on. The first thing I noticed was it was easy to pull. There was no problem. And even with this steel being so strong, this thing's 53 foot long. You know, you got crazy leverage to flex something when it's that long. If you got a bow in something that's 4 inches in the middle and it's 4 feet long, yeah, you got a problem. But if you got a 4 inches in 53 feet, that's not that big a deal. But what I found whenever I just bolted that center beam in there is it took about half of that bow out. I'd say I've got less than 2 inches there now. If I run a string from end to end and measured the center, I'd probably say I got about 2 inches. So what does that tell us? What does that mean? That means if I fabricate that other piece just exactly like I did this one, and we bolt them together, then we're not going to have an issue with it being warped. It's probably going to straighten itself right out to the extent that you would probably never even know it was warped. So I think we're all good on that. Another thing to make note of that I messed with there yesterday is I'd said before that this bridge is going to be built on an angle. It's going to have, you know, a slope to it. Erect something like that, whether you're using a boom truck or we may set this with a telehandler. It's however you're going to do it. If you're setting something that's on an angle, it's nice to get that steel pretty close to the angle it's going to be set before you set it. And what I mean by that is if you can make a lifting point to where when you lift it up it'll be sitting there at that angle, then that's a lot easier to set in place. If you're lifting something level that needs to be on an angle and the one end hits first and the other end's floating around in the wind, it's a lot harder to erect and build something that way. If it needs to set on an angle, you need to fly it in on an angle. So yesterday I was playing around with that center beam and I continued to lift it up at different points in it until I got it flying by itself on the angle that we want to build this thing. And I took a measurement from the end and I used that measurement to make a mark on this piece, and I ran a bar across there and I tried to connect to that bar and lift it and see if this lifted on the same angle. And what I found is that the difference in the way these channels are made it so that my bar wasn't in exactly the right place. I needed to grab it over that way a little farther. Well, no big deal. I added another bar here and then lifted around in this area until I found a place where I could lift it and get it pretty close to the way I wanted it. And that's what we got going on here. This is plenty strong enough to lift it with. I had it flying in the air for quite a while yesterday, and I was using my plate clamp to lift by until I found the spot, and then I burned that hole so we can put a shackle in that hole. And I've got this within, I'd say, 200 pounds of being perfect. I could climb out on it and make it perfect, but you know, it doesn't have to be perfect. It's just got to be close enough that it helps you erect it. You know, it needs to be flying close enough that you can get your hands on it and get it into the position that you need it. Now that those things are worked out, I'm feeling really good about moving forward with finishing up on this side. And what I'm pretty much going to be doing is exactly what I did to the other piece. I'm going to weld everything in the same way, in the same direction, in the same manner, and I'm going to hope that I get a bow in the same direction. And these two flexes or bows or whatever from the welding, you know, I think they're going to counteract each other in a way that there's not going to be a lot of stress in it. But even if you have to put a lot of stress in it to pull it together, that's not a big deal. It's not something that's really going to weaken the bridge. But I think we're good to go on this, and obviously now, since I've found that lifting point in that other piece, I can put a lifting point in this piece and probably do that a little quicker and easier now that I've goofed with that other one. And so I just wanted to make some quick notes on what's been crack-a-lacking here. I'm going to go on with fabrication and get this other side angle put on there and weld it on, and I got a lot of welding to do, so let's do it. All right, well, the way this has gone down within the last couple of days, you know, I got all the welding done, and then yesterday evening I thought I was going to put the primer on this thing, and yesterday throughout the day I cleaned all the structure, and I power washed everything, and I had it ready to paint. I used my blower and a couple other things, and I got all the steel dried off, and it came a damn rain. So I said, well, there's no way I can do this. So the next thing was I went in, I took a shower. I didn't think I was going to be able to paint yesterday, and it stopped raining. That rain that came through, it was just a quick squall and it was gone. So I'd already took a shower and stuff, but I was like, hell with it. You know, I might be able to at least get the primer on this evening. So I went and I came back out here. I got the blower. I blew all the water off of everything, and thought I was going to at least get the primer on yesterday evening. And as soon as I got everything dry, it rained again. And by the time that was over, it was dark. So the way it ended up being, I came out early this morning, and I got everything dried off. I blew everything down with the blower real well and got everything dried off. And I put the primer on, I put the paint on, and I had to kind of rush. There's weather coming, like it's going to thunderstorm tonight. So I used a lot of hardener in this paint. I actually could probably show you. I'm within 30 minutes of when I stopped painting. It's that dry. I went and bought $300 worth of hardener today, and I'm using Rust-Oleum paint, and I'm using an Acme 612 hardener. Probably a lot of people don't realize you can do that, but you can. And that hardener, it really makes her set up. But you know, if you use what I used here with regards to hardener, I was using a quart of hardener for 2 gallons of paint. So a pint of hardener per gallon, that's a lot. If you do that with Rust-Oleum right now today, you're putting about $32.50 worth of hardener in $40 worth of paint, which is you know, you got to do what you got to do. Like I said, we got thunderstorms coming tonight, and I do have a lot of runs in this paint. I mean, to put 5 gallons of primer and 11 gallons of paint on in one day out here like this, you know, that's really pushing it. But I've been watching the weather, and the fact is, if this ain't done today and dried before the thunderstorms tonight, this project could be delayed as much as a week. It's just the time of year, or the weather we're having now. You know, I don't have any way of putting something this big inside. Even guys I know that's got shops this big, we can't get it in there, you know, right now. I got to jump on and do what I got to do and get the shit painted, and that's what I did. And you know, it's with all that hardener in there, even though I've rushed to get all that paint on there, and I've got some runs in it. I'm pretty happy because I've got it all on there, and as dry as it is, I think even if we have a thunderstorm tonight, it's going to be fine. It's going to be fine, and I can move on to other parts of this project. Just making some quick notes on that. I've got loaded up and headed out. That low belly landau was close on that hill, but she made it. I don't know how many times you ever built a bridge and then followed it to the bridge site, but this is my first time. It's hard to play a gig in this town and keep a straight face. Alright, so let's put that other one in there. That'd be good. Gaps are right and the bolts are tight. I love it when a plan comes together.
Try not to get too mixed up.
Yeah, it turned out nice.
Oh yeah, that's it.
You going racing? Oh, today's Friday.
Any chance you picked my tennis shoes up over there?
Nope.